Okay, you are welcome. Today we are looking at this problem. It's a binomial theorem problem. Find the coefficient of x raised to the power of 6 in the expansion of 1 over x squared minus x all to the power of 18. Now, before I start this problem, I need to give us a foundation, and that is the expansion of a plus b all to the power of n, how the expansion will look like. So let's start with that. Before, I know we are given this a plus b raised to the power of n. Now, this expansion, the binomial expansion of this will be a raised to the power of n plus n combination 1. Then we have a n minus 1, then b. So let me copy this so that I'll be using it. Then the next term will be this will be 2. So we have something of this nature now. So we can put some ellipses here. So ellipsis is used for brevity. To show that also for that to show that there are some terms that still exist. So each term, as we keep on expanding, we have this expansion. This will be the pattern for every binomial expansion that we are given. So plus, so we can also have, we can still have this. So until we get to the term, this particular term, so n minus n, that will give you 0. Anything with the power of 0 will give you 1. So you have this. So this will be the expansion for a plus b always to the power of n. That will be the expansion that we will get. Now for this particular term that we are given, the expansion, the pattern of the expansion of this man. Now this man, so this man, just don't worry. Now this man, we can rewrite it because we have a plus b raised to the power of n. So we can rewrite this as 1 over x all squared plus, so we have minus x here all raised to the power of 18. That's what we have for that. So we have that. Now the pattern for the expansion of this. So for the expansion of this, the pattern for the expansion will be like, the pattern for this expansion will be like 18, where 18 is your n in this case. 18 combination r 1 over x all squared into n 18 minus r. Then we have minus x raised to the power of r. Don't forget that this man that we have here, same thing as plus. So just want you to take note of that. So we have this. This will be the pattern for this expansion. So we have this expansion now. Now what we need to do is to work with this term. We need to work with this term. So I'm going to do that now. So what this one is same thing as 18 combination r So we have x raised to power minus 2 is equal to 18 minus r, then minus this minus x is the same thing as minus 1 minus x raised to the power of r. It's the same thing. The same thing. So we have this expansion now. So I want you to, after you have gotten this expansion, now imagine that only x raised to power of minus 2 and x are existing, and are existing. So let's imagine that only x raised to power minus 2 and x are existing. So what we have here, imagine that only x squared. So what we need to do, let me bring this down so that you see what I'm saying. Now just imagine that it's only this term that's existing. So what we have here, just x raised to power minus 2 raised to the 18 minus r. So then we have x raised to the power of r. Imagine that the others are not existing. 18 combination r is not existing. Minus 1 is not existing. These are the terms that are existing. So this will be x raised to power 2r plus minus 36. X raised to power of r. So that is it. So what we have here is, now you have something of this nature now. So we can have 3r following the law of indices. When we have two indices being multiplied together, they have the same base. So just add the powers. So we have 3r minus 36. So now we have this. This is what we have. Now what we need to do now is we are asked to find the term, the coefficient. If I look at the question, it says we should find the coefficient of x raised to the power of 6. So we can invariably equate, so for x raised to the power of 6 term, for x raised to the power of 6, so we now have x 2r minus 36 is equals to x raised to the power of 6. So this will now be x. So equate the powers. You can say 2r minus 36 is equals to 6. So our r, this is 3. This is 3. So there's an error. This is 3. So we have that. So 3r is equals to 42. So our R is equals to 14. That means divide both sides by. Now we have gotten these values. Now I need to explain certain things to us. This expansion, the pattern for the expansion of this will be like this. So we normally have we normally call each term each term of the binomial expansion of the binomial expansion is called, let me use R plus 1 term. The R plus 1 term. So now the R plus 1 term plus 1 term, the R plus 1 term of the expansion expansion. So the R plus 1 term of the expansion for this one is this. So which I'm going to copy out. So this is now let's come back. So we are gotten our R to be 14. Now we can put that 14. So substitute 14 for R in the R plus 1 term pattern. So now what we need to do now is we just substitute this our R plus 1 term. So we substitute that. Let me just copy it. So we substitute 14 anywhere we see. So we substitute 14. So this is 14. And this is 14. And this is 14. So for the sake of our class, I want you to see it. So we have 18 combination 14. That's 3, 30, 60. 30, 60. So we have that. So and then by the time we expand this will give us let me write this. This will give me x raised to power minus 2, and then this one will be 4. Then this one will be, by the time, because 14 is an even number, so that minus will change to plus, so we have x raised to power of 14 there. So we have 3. So that one will be x raised to the power of minus 8 bracket, and then we have x raised to the power of 14. Now, if we following the law of indices, 14 minus 8 will give us 6. So we have 3 x raised to the power of 6. So they ask us what's the coefficient. So the coefficient the coefficient is the coefficient of is 3060. So this is how to go about solving problem like this when it comes to binomial expansion. So I'm going to see everything on one page. So we have this expansion. So you can go over it. I'll still work more. Let's take this as part 1. We'll still solve more problem on binomial theorem so that you can see how to go about solving problems like this. And if you're interested in getting more videos like this, interesting videos on solving problems in mathematics, you can please subscribe to this channel, like this video, and share it with other people also. So thank you for watching. So see you next time.